Welcome to the second module on open source database on Microsoft Azure. I'm Damien Caro, Technical Evangelist Manager at Microsoft.
And I'm Oğuz Pastırmacı, Technical Evangelist in Microsoft.
So in this module, we're going to cover storage and performance. And we'll drill into the consideration around those two topics. We will have, of course, the storage account. We will talk about the VM size, and we will see how those two elements combined can impact the performance of the machines, which by definition will drive the performance of the database. So we'll see the different VM options that we have, that you have in your environment. We will cover how you can design, and you should design your disk architecture to get the best of what you are consuming. So basically getting the best, if I shall say, return over investment. We'll talk about storage account, and we will finish by a light touch on premium storage, which is a feature capability of Azure that has been announced recently. It's a super cool feature, but that's why we keep it for the end.
It will be a light touch, but the feature itself is just very, amazing.
Oh yeah, it is. Let's run into the VM options. Storage account considerations. The first thing you consider is the different storage options. We've briefly covered the MySQL in Azure as a service that you have, but there are other solutions as the Azure Files. Azure Files is like a file share that you have in Azure where you can drop your database if you want to do it. I do not recommend doing that for pure performance consideration, as the third option called Blob Storage has actually a better throughput and better performance for that kind of things. Azure File is great for other solutions, but for database, I definitely recommend to go for Blob Storage or MySQL Azure as a service. That's what we've seen into the first module. You have to consider, though, that a storage account has a limit of 20,000 IOPS. So if you take the whole storage account as a whole, the limit is 20,000 IOPS, and you will not be able to go above that. So that's something you want to keep in mind when you get there. The storage account with the blob storage is where you will basically put the disks that the VM will consume if they run as a VM. And those VM have different characteristics. So in Azure, when you create your own VM, Linux or Windows-based, it actually doesn't matter, you have different sizes, different capacity. The first one, which is usually this is where we started basically, is a general use VM. The general use VM have a balanced approach between compute power, number of CPUs, and memory. Those are the main criteria we look at. The main reason is that storage, the disk of the VM, the disk that comes with the VM, is not a matter because you can always add additional storage by adding data disk. And we'll cover the data disk later in this module. So general use VM have a balanced approach between compute and memory. And they are divided into two tiers. We have the basic tier and the standard tier, which have different characteristics and different properties. This is under what we call the A series. Then we have a couple of VMs that are network optimized. The network optimized VM have characteristics around making sure we get the best network throughput. They're usually used for HPC, high computing power solutions. We will see, but they may not be the best solution for database. And the last series is the VMs that have been optimized for computation, and they land into two categories, the D and the DS series and the G series. Those two series have different characteristics in terms of ratio of RAM per core, and we'll drill down into that in the next few slides. But you have to remember basically that we have the general purpose VMs, the network optimized, and the compute optimized VMs. So the general purpose VMs, the A series, they fit into the A series. Basically, they're under those two categories, the basic VM. Basic VM have a maximum of 300 IOPS per disk. And that's going to cap. So if you add a couple of disks, the number of IOPS will be limited at 300. The basic VM have absolutely no access to the Azure load balancer. So if you want to create, let's say, a cluster of VMs that are load balanced on the networking side, you will have to go to a standard VM. And each VM in the basic VM characteristics have a maximum capacity of 16 data disk. Depending on which VM we take, they have a different maximum number of data disk. So if you look at the graphic tries to put in perspective the number of cores and the memory along with the data disk. So the A0 basic VM is basically the cheapest VM you can find. It has 2 cores. It has up to it has 4 cores and 2 gig of RAM, and then it grows. And the ratio number of cores versus the number of RAM is roughly constant. So the ratio evolves. The standard VMs, though, have a different characteristics in terms of disk. The amount of IOPS per disk is 500. So you get a better throughput on those VMs.
So this means, let's say I added 16 disks. I'm going to get 500 IOPS per disk. It means I will get up to 8,000 per that VM, right?
Let me make the math. Yes, that's correct. So basically you add the number of IOPS per disk as you go with more disk. Number of data disk is a maximum of 16, and that is for the A4 VM and the A7 VMs. That's where you get the maximum number of data disk. As you can see, the amount of RAM for the A7 VM is 56 gigabytes, which is pretty good.
Pretty good, yeah.
I mean, it starts to be a pretty decent size VM. But it can go higher than that. Those are the numbers as of today. And again, it, of course, can evolve over time, but this is the current layout that we have for those VMs.
I also remember in the past we were naming the virtual machines like t-shirt sizes, like X small, small, medium, but then it became impossible to add because we'll show that the number of virtual machine configuration is like a very, very large list today. So this is the reason we changed all the naming convention from t-shirt sizes to a more consistent A series based naming convention.
Yeah. Absolutely. And those sizes are available on the internet. You can go to the, I will show you the page, but you can go there, review the size of the VM, and you can play with I would say the configuration tool, but you can actually drill down into every single technical detail of each VM.
Mm-hmm.
So we've seen the general use VM, the A series for general use. Now we have a couple of VMs, the A8 VM and the A9 VM. Those two VMs are network optimized. That means not only they have a faster processor, so they run on physical processors which are Intel Xeon E5 at 2.6 gigahertz. So it's a rather fairly new generation of processors. They have DDR3 RAMs at 1.6 gigahertz as well. But they also have access to a 10 gig Ethernet card that give access to the Azure services. So you can use those VM to go to storage, Azure services, VNets. So that gives a better network throughput. If you want to run an app that has the requirement of network performance, those are the VMs you want to go to. The number of data disk is about the same. I mean, for both of those VMs, the maximum number of data disk for those VM is 16, with 500 IOPS per disk. So we get to the same amount of IOPS per VM that we talked about, 16 times 500. I'm bad on math.
Open calc exe.
I'll open calc and exe and make the math. So let's drill into another set of VM, which is, again, a new beast. We've announced those VMs recently. We've announced those VM recently. The D series, D like Damien, I love it. So the D series, not only they have a faster CPU than the A series, but they are really compute optimized. The amount of RAM that those VMs get can be amazing. So if you look at the VM size, you can see that the VMs are basically split into two categories. We have the D1 through D4, which have a ratio of 3.5 gig of RAM per core, and we have the D11 through the D14 series, which have a ratio of 7 gig of RAM per core. So depending on the workload you want to run there, you may want to go for a D1 to 4 or a D11 to D14. So that's basically how those VMs are grouped. The D14 series machine can go up to, if you look at the number, it's the, let me bring the laser. That's the peak of RAM that you will get on a D series VM. That's 112 gig of RAM.
Cool.
So it starts to be a decent VM. I'm not saying this is the biggest VM, but it starts to be a decent VM. The D14 series can have up to 32 data disk. Mm-hmm. So again, we're talking about 32 times 500 to count the maximum IOPS you can get. If you get all those disks attached to one VM, again, I will need calc to get to the number of IOPS that it brings, but that's pretty interesting. Additional, those D machines, their characteristics is to have an SSD, or local SSD drive that has a size that goes up to 800 gig. It means that the temporary drive, the /MNT or MNT resource, depending on which distribution you use, is going to leverage the SSD drive that is going to be locally on the physical host where the machine resides. The thing we have to pay attention to is that it's a temporary drive, and the temporary drive may be lost. So you don't want to store any data there. It's very good for databases that are spread or replicated amongst different VMs. I mean, the local storage very unlikely will break, but it may happen. It's something that you may want to consider at one point. But if you have a database that has multiple replica, thinking of MongoDB, for example, you can actually have multiple instances running with their database on the local cache. And it doesn't matter if the cache is riffed, because you guys basically get the data again from another copy.
Exactly. If you have a distributed application, that's a great candidate for that types of application, because just like you mentioned, the application doesn't care if the data stays in that disks or not. It just, if it's not there, it just replicates from one of the other nodes in the distributed system.
Yeah. So that's really something you want to consider for that kind of application. It's perfect for this. In the Microsoft world, it would be SQL and replicas of SQL database as well. But yeah, MongoDB is a real good example for that one. So D series, the difference between the D and the DS series is the ability to get attached to premium storage. So we'll see premium storage later today in this course, in this module actually, to see the characteristics and what it brings to the VMs. But that's the main difference between the D and the DS series. Haha. I like this part. The G series. So the G series, why G?
Godzilla.
Yeah, G is for Godzilla. That was the nickname of those VMs internally.
And the name suits the configuration. I have to say that.
It totally suits the configuration. We'll come to basically who has the biggest machine in a minute, but I like to say this is the largest VM in the cloud as of today. It runs on those Xeon E5 V3 CPU families. You can go up to 32 virtual CPUs in one VM. If you look at that's the G5, that goes up to 32. You can think of 6.59 terabyte of local SSD storage. Terabyte, not giga.
Yeah.
Terabyte. It's 6,590 gigabytes, and it's big. Local storage. So you want to think of that for large VM that have replicas and things like that. The ratio of RAM per CPU per virtual core is double from what we had in the D series. So now we go to 14 gig of RAM per virtual CPU. Think of doing the math. 32 virtual CPU times 14 gig of RAM, that brings us to 448 gig of RAM for the G5 VM.
In a single virtual machine.
Single virtual machine. 448 gig of RAM. You have to be careful. The credit card will be hit. The price is in consequence. But if you really need super large VM for, I don't know, temporary compute, you really need that size of VM, you have it. It's available. We pushed the limit so much on those G4 and 5 VMs that if you run a Linux environment, you need to update the Linux agent if you're running the agent prior to December 2014. So the temporary storage will not be formatted correctly. So the agent has to be updated either in your image or you just re-download a new image from the gallery that we've seen and you redeploy that VM on your environment.
So even if you don't need a very serious amount of workload, you can just go with A series, even A0. That's an option. But if, let's say, you're in university doing high-performance computing tasks, doing some calculations, we have what you need. So you have all the options you may need in your enterprise scenario, or even if you're a startup scenario, available in Azure. And as just like you mentioned, the G series VMs are the largest one in the cloud. Correct.
That's exactly the way we look at it, giving you options to go where you want to go. So we've seen the different options on the VM size. Now a VM comes with disks. And it is important to consider or to keep in mind few things when you talk about disk architecture. You have the operating system disk. If you use the standard supported image from Microsoft, they will come with a local disk, which size depends on the different distributions. Usually it's like 30 gig. It is recommended to not use the /dev/SDA for application storage because they're not structured for that. They're structured for fast operating system boot, not for data applications. So I really, really recommend not using the OS disk for database, unless you want to do a test quick and dirty. And the cache on the operating system disk is read and write. So you want to be careful with that because, again, if you put your data on the disk that has local write cache, in case something happens, you may corrupt your database. Then we have the temporary storage. The temporary storage is under /dev/sdb. Again, don't use it for permanent storage. You can use it for temporary activities or for storing a database that has multiple replica, as we talked a minute ago. And you have the data disk. The data disk have a maximum size of 1 terabyte. I recommend to always create disks of 1 terabyte because at the end of the day, you're going to pay for the space you're consuming. So if you put a 1 terabyte data disk, you have the ability to grow. If you have a smaller disk and you reach the limit of your disk by adding data, resizing a disk in Azure is painful. I've tried, I had to do it a few times, and I can say it's quite painful. So you don't want to go there. So go with a 1 terabyte disk, put whatever data you need, and you'll pay for that consumption of the disk. The free space is not going to be charged. So it's the right thing to go, the right way to go.
So basically we can say add the maximum number of disks with the maximum amount of storage size, because you won't be charged by the number of disks or by the capacity you have added, but you will be charged by the actual amount you will be consuming on the disks, right?
Correct. But the more disk you will put on a VM, the more complex it will become. So you want to balance that. You want to balance the complexity versus the cost. And if you have each VM with 16 disks and you need to move them around, that's going to be a bit tricky to do that. The data disk will appear under the device directory, and it will be like SDC if this is the next one we do. Let's have a quick look on that. Let's have a quick demo on the disk architecture, on how we add a disk on a Linux VM and see how it works. So let's switch to my demo environment. So I'm already connected on my machine. Let's see what I have. Yeah, I've already prepared the command line to gain some time. We see we have the local storage, local disk, and we have the temporary disk. So I'm going to switch to my Azure portal, and I'm going to add a disk on that VM. So I'm going to, through the new portal, which I recommend to really have a look and try to be familiar with. I'm going to the properties of my VM and go in the settings. So the settings open a blade where I can add multiple things, including disk, and that's the one I'm going to do. I'm going to add a new disk. Of course, we could do it through PowerShell. We could do it through the command line interface. I'm just going through the user interface on the portal to better understand what we're doing. So you see, we already have the operating system data disk. That's an Ubuntu VM. I told the VM size generally is like 30 gig. This is the case in this environment. And I'm going to attach a new empty data disk on that VM. So I'm just going to add a storage container into an existing storage account. The storage account has to be in the same region than the region where the VM runs. So you cannot have a VM running in Western Europe, for example, and have a storage account in West US. That will not work. So that's why when I selected my storage account, because my VM is already running in the US, I could only go to storage accounts that are based in the US, but all the accounts that are based in Europe were grayed out because they were not in the same region. So I have my storage account. I'm going to select the container where I want to put my disk. The VHD container is good. By default, Azure creates a disk with a name that has a timestamp. So it has the date and the time. Then we need to specify the size in gigabytes. And we need to define what is the cache that we want. The default cache for a new disk is no cache. But you can add read-only if you do, or you plan to do a lot of read operations. If you plan to add read and writes, you may want to go for the read-write cache to get better performance. Although you have to be careful on the cache because you never know what may happen.
Just one point I want to add. For testing, you can just leave the name as it is. But if you are planning to do any production deployment, please, please, please have a naming convention plan and stick to it. Because if you are going to add 10 disks to that virtual machine, it may be a little bit hard to find out which disk was this, if you want to remove that disk, that kind of thing. So not only for disks, anything you are creating in Azure, it's great to have a naming convention plan and sticking to it.
Yeah, absolutely. Because you will see in the demo, actually that disk will appear as SDC, but then there is no way to connect the SDC with that specific disk. So the naming convention is highly important for that. So we're good. We've attached the disk. Let's wait for the data disk to appear. Now it takes a minute to refresh the portal. I mean, this is still in preview. It takes a bit of time to get the disk on the list. In the meantime, we can jump to my VM. See if I see the disk. Not yet. Oh, you see the notification on the left? So you don't have to wait for and refresh the page. You can even go somewhere else, and the new portal will bring those notifications right to your screen, so you see exactly what happens.
Maybe to mention again, the new portal is in preview, meaning you may have small glitches like this, but it's not affecting the way it works. So you can see that the disk is already in the virtual machine. You don't even do anything. You don't even need to do anything inside the virtual machine. It just sees the disk.
Correct. It just sees the disk, appears on the device, and now we can mount it as a real disk on the Linux environment. So I'm going to try to type correctly my command. I'm going to format that disk. Oops. Yeah. SDC, we're good. Yes. I'm going for the quick and easy, dirty approach. So we have our disk formatted. If I do an fdisk, we should see that my disk with 21.5 gig is available. It's connected. It's under dev SDC, and now I can mount it. New disk. Yep, we have the disk. So let's switch back to the slides for a couple of minutes. So we can talk a bit about different elements around storage account and consideration around how you create those storage environments. So the thing you have to keep in mind is storage account have a maximum of 500 terabytes of data. There is no limit in number of objects, but 500 terabytes of data per storage account. There is a 20,000 IOPS limit per storage account, and the maximum file is 500 terabytes. Of course, that's the maximum size of storage you can have. We have different replication options when you create storage account. The first one is to have a local storage. Local storage means you have 3 copies of each data disk in the same data center, in the same region, we should say. Meaning that in case of a failure on one of the storage, we still have 2 copies at least, and at every point of time, we have 3 copies of those data. But we also have the ability to have geo-replication. So in case of the US, you can have a copy of the West data center, and you have a copy in the East data center, and those data will be replicated in real time. I mean, real time, it needs some time to get through, but the data will be updated as it goes. Before we hit premium storage, I want to highlight that it is still in preview. We are accepting people, and we are accepting nomination for premium storage. But for most of you, if you just apply for it, you will still be on the wait list, and we open that program to additional customers as we go.
And also, if you have virtual machines using premium storage for testing, make sure you shut them down when you're not using them.
You mean it can burn your credit card?
Your bank can call you.
Yeah, you want to be careful there. So premium storage, it is based on SSD disks. So that's the main characteristic, and that's why we have better performance there. The premium storage is locally redundant. Connecting to what we've just seen, it creates 3 copies in the same region of the data, still on premium storage. The only type of content that it's supported is Azure Page Blobs. So Azure Page Blobs can be VHDs for virtual machines, but it can be also files, it can be anything you want to upload, but it has to be uploaded through the Azure Blob. The default disk configuration in this environment, in the premium storage, would be read-only for data disk and read-write for operating system disk. It would be very similar like any other storage, but that's the default configuration. The disk capacity in a storage account in premium storage is 32 terabytes. That's the disk capacity. And you have the ability to create snapshot of those disks. The amount of data that the snapshot can represent is 10 terabytes. Note, it doesn't include the base disk. So if you have a disk of 20 terabytes, it will not count against the snapshots that you're going to do on top of that. It's just the snapshot volume that is 10 terabytes. And we have a limit on the throughput that premium storage allows. So the limit is 50 gig per second for inbound and outbound. We consider the I/O unit of 250K. Let's make some math in a different way. So, when you create a new disk in a premium storage account, depending on the size of the disk, you will have different characteristics. You will have different properties. It can be a disk, let's say, 128 gig. The 128 gig disk will be a type P10. It will bring 500 IOPS per disk at a throughput of 100 meg per second. So that's the characteristic. You know you can write or read up to 100 meg per second. The P20 has bigger size, more IOPS, higher throughput, and the largest one, the P30 for 1 terabyte disk, will go up to 5,000 IOPS with a throughput of 200 meg per second. Now, how would that work if you don't want a disk of 128 gig? Well, we round up the size to the upper limit of the next typical drive. So if we take a disk of 400 gig, the 400 gig disk will be a P20 type because it's the closest one going up. That disk is going to be a P20, but it will be a 400 gig. So we don't round the size, we just round the type. If the application, let's say, run 495 IOPS on a P10 disk, and at that time, you want to add 2 megabytes of input and output for other activities. If you consider the math, 2 megabytes divided by 250K is equal to 8, which means you need 8 additional IOPS. You already are doing 495 per second. You add 8 IOPS on top of that, it's 503. So what will happen is the storage will cap your capacity at 500 at this specific moment, and those IOPS will be delayed, or they will be handled at a later time. Let's burn some money?
Yes. How do we do it?
So, I'm going to switch to my demo, to my account. Again, going to the preview portal, and for the premium storage, you have to go through the preview portal. I'm going to click New, and I'm going to click Everything, so I can see everything. And I type storage. I'm lazy, I just don't even know where it is, I just type storage, and the portal will actually bring everything that has storage. What I'm interested into is this one, the orange box that says Storage by Microsoft, and it will allow me to create a storage account. So now we are in the blade where we define the storage account. So we need to give a name to the storage account that is unique. MVA is used, demo 1. That works. So let's create MVA demo 1. We need to select a subscription that has access to this environment. So I'm going to take the subscription that has access to premium storage. And you go to the pricing tier. The pricing tier will actually define which type of storage you want to use. So by default, I have the G, L, and the R. The difference is the properties in number of IOPS, local replicas or geo replicas, and the difference between read-only or not read-only to the secondary copies. I'm interested in premium storage. So you have to browse, you have to ask for browsing all pricing tiers, which brings the blade of the premium locally redundant storage. That's the one I'm going to select. We're good. We have our local copy, premium storage, location. Maybe you want to put it in the US. Yeah, we should put it in West US. And we're pretty much good. So has your manager approved that?
Hopefully.
So let's go. So we are creating a storage account. And once we have the storage account, we will be able to create a disk in that storage account. And eventually we could add that to our Linux VM.
Just to add one thing, the prices that was on the screen when you're creating the premium storage account was in Turkish liras. It's because this account is tied to a Turkish address. So the prices you have shown are not US dollars.
No.
The conversion rate is like 1 to 2.5. So be sure to check the actual prices from the pricing page that you're showing here in Azure portal.
Yeah, you have on the Azure portal the ability to evaluate the different pricing with a calculator. So you go to azure.microsoft.com/pricing, and it will bring you to the pricing calculator where you can actually simulate how much your infrastructure, your environment can cost based on Linux VM and premium storage and everything. So we have our premium storage available. It's there. We can create a container. We can make it private, or we can give different level of access. I'm good with default. The container has been created. And now if we go to our VM, go to the disks, we could attach a new disk. That should be attached to. We're in different regions, so you see we will not be able to attach this. But if that VM would be in the same region, we would be able to do it, and we would have performance that are amazing. Let's put it this way. So that pretty much concludes our demo on premium storage. So what we've seen in this module, we've seen the different characteristics around a storage account. We've seen the different elements to consider for the size of the VM, the A, the D, the G series, the basic tier and the standard tier for the A VMs. We've seen the number of IOPS that each VM can address based on the storage characteristics, the disk characteristics. We've seen how you actually mount a disk, and you can use the disk on a Linux VM to prepare for your MySQL, for your MongoDB, for your different type of open source database. And then we've lightly touched premium storage, which allows you to have better throughput, better performance for permanent storage. And you can attach that storage to a Linux VM. You have all the resources available on MVA, but stay tuned for the next module on this course where we will talk about
how are we going to maintain high availability when we are building this storage infrastructure and network infrastructure in Azure.
Stay tuned.